Hey guys, this is homework 10.4 question number 1. It wants us to find the measure of A, B, C, and D. A and B are on the outside. C and D are on the interior of the polygon. So we're going to use the same formula that we were given for inscribed angles, but we know that the inside has to add up to 360 because this has 4 sides, or it's a quadrilateral. We also know that the outside measure has to add up to 360. So we have to be careful here when doing that. We're going to have to make sure the outside adds up to 360 independently of the inside adding up to 360. So A plus B plus C plus D will not equal 360 because we are looking at the inside and the outside. So don't fall for that. So let's look at what we will need to do. Let's start with A. So with A, we need this arc in degrees. Now, I don't have any way to know what that is. I don't have, like we learned before, this central angle. I am just given the angles inside this quadrilateral and some of the angles on the circumference. So how would I do that? Well, I have a formula that says the interior angle is equal to 1/2 the two angles that create the intercepted arc, or the two arc lengths. So I'm going to call it arc 1 plus arc 2. Let's put that in a much easier way to see by actually solving it, because these really are the easiest way here. So if I want A, I can look at the lines that generate from the polygon A. Well, I have this one. And if I go this way, I'm not actually looking at that piece of arc, so that's not going to work. What I need to do is I'm going to start right here, and I'm going to trace it back along the polygon. Everything in this arc measure is what I need. So now I know to get this 107 degrees, that's my interior angle. I'm going to say 107 degrees is equal to 1/2 of arc 1 plus arc 2. So arc 1 is 94 and arc 2 is A. Now I can just solve to get rid of this 1/2. I'm going to multiply everything by 2. And I'll have 214 is equal to 94 plus A. I can now subtract 94 from both sides. That's going to leave me with 120 is equal to A. Now to find B, I'm going to do something very similar. Actually, let me go ahead and erase all this. So what I'm going to do for B now is retrace my polygon for the angle that created it. And hopefully that'll work out. Of course, I'm saying hopefully because I already know ahead of time that that's not going to work. And we're going to have to do some more fancy stuff. And that's why I mentioned the sum of the circumference measures must be 360. Now we need B. We need this arc right here. So now, if I follow my same steps, I would start here, trace it back to D, and then that. Well, we've got a problem there, and that we don't have D. We can't have two variables, so that's not going to work. So how do I move forward? Well, I can try here. Sorry, no, I can't. It has to be this one to do this whole piece. Well, now I have D and B as variables, so that's not going to help us at all. Excuse me. So now I have to figure something else out. Well, I happen to know now that this is 120, and I know this is 94. If I were able to find this piece, this arc, then I can add these three together, subtract it from 360, and I'll be left with B. So that's how we're actually going to proceed here. Why is that important? Well, if I start here, and I go to here, this arc measure right here gives me 98 is equal to 1/2 x plus 94. So let's go ahead and solve for it. So 98, that's my interior angle, is equal to 1/2 arc 1 x plus arc 2. And arc 1 and arc 2 don't matter because it's the commutative property. We can add these in any order. So let's do, again, multiply both sides by 2 to get rid of the 1/2. That cancels, and I'm left with 196 is equal to x plus 94. Subtract 94 from both sides, and I get x is equal to 102. So that piece right here is 102 degrees, and that helps us because now we know that we have 120, 94, and 102, and b. So if I wanted to solve for b now, I can say 102 plus 94 plus 120 plus b equals 360. These two together is 196, plus this will be 316. Bring the b down. Let me get the calculator to double check that one. 102 plus 94 plus 120. Yes, 316. And then subtract 316 from both sides. B is equal to 44. So again, the exterior angles, or the exterior angle measures of a circle must add up to 360 degrees in a circle. So I'm going to erase all this. It's going to take a few minutes. And then we're going to pop in for B that it is 44. And now you can see the reason I did it this way is so that it's easier to see that we've already accounted for all 360 degrees on the exterior. So now we don't have a reason to cross-contaminate or look at CD and AB and adding them together hoping to get to 360. So let's put here, this was 44. So I'm going to go ahead and come back here. This was 120. This is 44. Just so we can look at it if we need it for C and D. Okay, now we're going to do things a little bit different. Before we had our interior angle was already given to us. Now we're going to be solving for the interior angle because we need C and D. So now looking at C, these two lines, if I trace them out to the circumference, create this intercepted arc. Whoa, why am I on erase mode? Cool. And this intercepted arc is equal to the interior angle, which is C. So I'm going to go ahead and put C is equal to 1/2 of arc 1 plus arc 2. So now I'm going to have C is equal to 1/2 of 166. 164. Ooh, good morning. And 1/2 of 164 is 82. So I can say C is 82 degrees. Now we have two ways that we can do D, and I'm going to do both of them so that we can verify that we did them correctly. And that is, since we have a quadrilateral, we know the sum of the interior angles must be 360 degrees. So I'm now going to say that 98 plus 107 plus C, right, because I've done this one, now I'm going to add C, which is 82, plus D must equal 360. So 98 plus 107 plus 82 is equal to 287. So I'm going to do 360 minus 287. And I have 73. So now how would I set this up? Pause the video here and see if you can set it up. Hopefully you actually paused the video and now you're coming back to check to see if you got the answer right. Let's see if we did. We had 73 as our answer. But we're going to verify that. Oh. So let's go ahead and put down 73. We did it the old chapter 6 polygon interior angle sum theorem way to verify, but now we're going to go ahead and do it using this new formula since we need practice. We have here D is equal to this arc length plus this arc length divided by 2, or 1/2 of this arc length plus that arc length. Now, do we remember what this number was? I know you guys can look down. I didn't write it down. It was 102. So to do this one, I'm going to do D, or my interior angle, is equal to 1/2 102 plus my second arc, which is 44. And that's going to give me D is equal to 1/2 146, and half of that is 73 degrees. So now we verified that that is correct for our interior. We've done it 2 ways. We've gotten the same answer, and that's how you do the question. So let's check it back on Pearson. 120, 44, 82, 73. All right. Guys, here's the definition of looks difficult, but it's extremely easy to do. We've been given this circle with all of these chords drawn through it, creating tons of inscribed angles, and it just looks like a nightmare. And we have a 1, 2, 3, 4, 5 part question. So let's just jump right into it. This one's actually much easier than it appears. We're going to start with the measure of angle A, and that is this one right here. And remember, this formula that we were given before is your inside angle is equal to 1/2 of the outside angles, or arc, sorry, arc 1 plus arc 2. But if I look at angle A, I have 1 arc. So what I can do here, which is really nice, is just do 86, that's the arc created by angle A, plus 0, or what is 1/2 of 86? Well, 1/2 of 86 is 43. Anytime you only have 1 arc, or you have your angle that it generated and it's asking you for the arc that it generates, you're just going to double the angle, or if you're trying to find the angle like we just did, you're going to divide the arc by 2. So now let's look at CE. What is the measure of arc CE? Well, CE, again, there's only 2 lines, there's a singular inscribed angle here, and we know that measure is 21. Well, this angle is 1/2 of the length of the arc, but if I have the angle, don't I just double it, right? So let's show you what I mean. So we know the inside angle is 21 degrees, and it's equal to 1/2 of arc CE. Well, to get CE by itself, I'm going to multiply both sides by 2, and I'm going to see that I get 42 is equal to arc CE. Measure of angle C. Normally I would say I'm going to stop here because it's the same stuff over and over again, but E is different, and there's 4 questions just like this on the homework, so I'm going to go ahead and do the whole thing. So the measure of angle C, these 2 inscribed angles from C create the measure 86. So what is 86 divided by 2? 43. All right. Sorry, I wanted to wait till I heard an answer there. All right. Measure of angle D. Oh, let's look at D. D is opposite of 42, or 82, sorry. So the angle that generated it is 41 degrees. Now we have our one that's quite different, but not really. If you watched my video on how to do question number 1, we're going to do the exact same thing here. I'm going to change colors. I know it's getting a little messy, but we have flown through most of these. So the measure of angle ABE. So start at A, go to B, and go to E. So we need this angle right here. Well, we know this part's 21, so that's good. Now, if we know this is 82, and we know CE is 42, we can, to find this angle here, we're going to call it big B. It's just equal to 1/2 of 82 plus 42. 82 plus 42 would be 124. And 1/2. So 1/2 of 124 is definitely 62. So the measure of angle ABE is 62. Let's check our work. 43, 42, 43, 41, 62.